So this first unit is all about things that you should already have learned before you got to pre-cal. Things that you learned in Algebra 1, Geometry, and Algebra 2. So the first topic that we're going to talk about are exponents. So when we're talking about exponents, there's a couple of rules that you need to make sure that you know in order to be successful in pre-cal. So the first rule, you need to make sure that you understand what an exponent looks like. So obviously this is going to be your exponent base. This is your actual exponent. Okay, and exponents are just repeated multiplication. So if you have something like 2 times 2 times 2, that's really 2 to the third power. So the exponent, again, represents repeated multiplication. Okay, there's a couple of symbols on here that every once in a while are going to pop up, and they happen in this section a lot. If you read through this, N, this symbol right here, okay, means is in the set. So this says N is in the set of N, where N is the natural number. So those are your counting numbers. So that's 1, 2, 3, 4, 5, not including 0, not including negatives, not including weird square roots or decimals, okay? So this says N is in the set of the natural numbers, okay? So I'm not going to read most of this sheet to you. I feel like you can read it. So let's just jump into the examples. So what they want you to do in this first set is express each expression in this form such that your exponent is one of the natural numbers, okay? So this one right here, you've got 1, 2, 3, 4, 5, 6 fives. So that's 5 to the 6th power, okay? So 5 to the 6th power. This one right here, I have 2 of the 1/2. I have 7 of the 1/2. And then this one with the invisible exponent, I have 1 more of the 1/2. So I have 2 plus 7 plus 1, so that is 10. So I have 10 of the 1/2. And this should be, again, something that you're pretty familiar with. This guy right here, so this -1 out in the front tells me that at the end, I'm going to put a -1 there, okay? So this is going to be 3.1 to the 4th, another 3.1 to the 3rd, but to the 2nd. So I have 2 groups of -3.1 to the 3rd. So when that happens, you multiply the exponents. So this is really the negative of 3.1 to the 4th times -3.1 to the 6th times -3.1 to the 5th. So I have 4 of them, I have 6 of them, I have 5 of them. So that's 11, 12, 13, 14, 15. So I have 15 of them with a negative in the front. So this is the negative of -3.1 to the 15th. Okay. All right, for D, it's the same thing just with variables. So I've got 4 of the -4s. I have 6 of the -4s. I have 5 of them, so that's 10, 15 again. So I have -x to the 15th. Okay, this should hopefully all be reviews, so that's why I'm going pretty quick. 3 and 4, so I have 12 of the 2s. And then this guy's a little bit different. Since they don't have the same base, I need to make this into a 2. Well, I know that 4 is really 2 squared. So this one is 2 to the 12th, and this guy is 2 squared to the 3rd squared. So I have 2 times 3 is 6 times 2 is 12. So I have 2 to the 12th times 2 to the 12th, which is 2 to the 24th. Hopefully that made sense. And then this guy, I have the same issue. I've got some 7s, and I've got a 49, and I know that 49 is 7 squared. So I'm going to rewrite this as 7 squared. And then this 9, I know is 3 squared. So this is 3 squared, 7 to the 5th, 7 to the 3rd, 3 squared. Well, hopefully you've been mathing long enough to recognize the fact that if you have something on the top and on the bottom, those two cancel out, right? And then on the top, if I have a base that's the same and they're multiplied, that means we're going to actually add up the exponents. So this is really 7 to the 7th over 7 to the 3rd. And if you have the same base divided by the same base, that means you're going to subtract the exponents. So this is 7 to the 4th. So altogether, that's 7 to the 4th. So hopefully that makes lots of sense. Here's a list of all of the properties of exponents that you should know. the rule about adding the exponents if they're multiplied, subtracting if they're divided, with some examples in here. So if those were some rules that were things that you were not familiar with, make sure you familiarize yourself with those pretty quickly. The other exponent rule that's kind of important is the rule for negative exponents, and that's going to actually hit a lot in AP Calculus, so this needs to be something that you're very familiar with. Notice this time that we have a base that's a real number, right? So B is in the set of all real numbers, okay? And N is in the set of all real numbers that are positive, okay? So N is in the set of all real numbers that are positive. So if you have a base raised to a negative exponent, that really means that this whole term is on the wrong side of the fraction, so it really just is the reciprocal. So hopefully that's something also that you're familiar with, and we can again jump into the examples. So if this is 2x to the negative fourth, that means this one's on the wrong side, so 2x to the negative fourth is really 2x to the fourth. Okay, the biggest problem that people have with exponents is that they see the negative exponent and try to flip the whole fraction. That's not what this means. This just means that this specific piece is in the wrong place, okay? So the same thing happens here. The 3 has an exponent of 1. The x has an exponent of negative 2, so that means it's on the wrong side of the fraction. So this is going to be 3 over x squared, okay? This time, the whole term 3x is raised to the negative power, so I'm going to put that whole term on the other side of the fraction bar. I'm going to keep it squared. But you can't leave the top of a fraction blank, so we'll put in a 1. So this is a good answer, or you could have written it as 1 over 9x squared, because you'd square each piece. So either one of those answers would be correct. Most of the time on the AP Cal test, they'll write them this way, unless there's something crazy, and then they'll leave them like this. Looking at D, the first thing that I notice is that there's a 4 and a 2, so I'm going to reduce that down to just 2. And then this y is y to the third, but this y is really y to the eighth. So then I'm going to use my exponent rules and say that I've got 3 minus 8, which is negative 5. So that means it needs to go in the denominator. So this is 2 over y to the fifth. So things like that are pretty commonplace. Hopefully, again, that's something that you're pretty familiar with. So those are your basic exponent rules. The other things that we can do with exponents are deal with rational exponents. And rational exponents deal with when you have a square root or you have some sort of root as well as an exponent. So the rule for that is written right here. I always like to say that it is power over root. So whatever exponent you're dealing with goes on the top, and whatever root you're dealing with goes on the bottom. So like right here, it would be the power over the root. So see, it's m over n. Same thing here, the power over the root, so m over n, okay? And you'll have to kind of convert back and forth from those things to those things. Okay, so let's look at this first one. So this is 3 times the fourth root of x squared. Well, this, if I do power over root, the power is 2, the root is 4, so this is x to the power over root. So this is really just 3x to the 1/2. Okay? So pretty simple. This guy is 4. I'm going to keep the coefficients and the constant on the top. But this is 2 to the power over root. So this is 2 to the 5/2. Okay? This guy right here, this is x to the 1/2. This is x to the 1/3, right? Power over root. And now I have 2 of the same bases, so my rule says I can add those exponents together. Well, if we're adding fractions, you've got to have common denominators. So this is 3/6, and this is 2/6. 3/6 and 2/6 is 5/6. So this is x to the 5/6 power. Okay? This guy starts to get a little bit more complicated, but again, that's okay. So we're going to kind of deal with each piece at a time. So we'll deal with the top first. If I'm squaring this, okay, this is going to be 2 squared, which is 4, okay? And then I'm going to square this power. Well, this guy right here by himself is x to the 2/5. Okay? And my rule for raising a power to a power is to multiply the two powers together. So this is x to the 2/5 times 2. So this is x to the 4/5. Okay, and then on the bottom, I have 3x to the 5/2. Okay, my rule for exponents, again, says if I have the same base on the top and the bottom, I can subtract the exponents. So I'm going to get both of these to have a denominator of 10. So we'll call this 8/10, and we'll call this, what, 25/10? So this would be 4/3. 8/10 minus 25/10 is, where do my notes go? 8/10 minus 25/10 is 17/10, and it's negative, and that goes in the denominator. So this is x to the 17/10. So again, a little bit gross of a number, but not the worst thing in the entire world. You'll also sometimes be asked to do things like this, 4 to the 3/2, in your head or on the non-calculator part. So the good thing about these, we know that this is the power and this is the root. And when you're dealing with bases that are numbers, you can apply either one of those first. So I know what the square root of 4 is, so I'm going to do that first. So the square root of 4 is 2. So this is now 2 to the 3rd power, which I know is 8. Okay, so hopefully that makes some sense, and you'll have to do that several times on the AP test. So hopefully we'll be good to go there. Here again are some of the properties of the exponents. So take a look at those. There's some examples if you're a little confused about things. Hopefully that makes some sense. And then the next video will be example 4.